Lesson 5.3, graphing radical functions. This is going to be a lot of calculator work today. So let's get started. First thing it asks us to do is just look at the parent function of the square root, right? So I'm going to type that in, y equals, you could type in f of x equals, if you wanted to, square root of x, right? And I see that the graph has a defined starting point, right? It starts right here at the origin. And that kind of makes sense because square root of 0 is 0. A square root of a negative, well, that's going to give me an imaginary number. And my calculator is not going to recognize that, right? So square root of 0 is 0. Square root of 1 is 1. Square root of 2, square root of 3 are irrational. Square root of 4 is 2, right? So my graph is going to kind of curve upward like this. So I'm going to get a domain here of x is greater than or equal to 0. And I'm going to get a range here that is the same. Y is greater than or equal to 0 because it has that defined starting point. For our first example then, right, we have a more complex function that we are looking at. And again, I am just going to graph it, right? So I'm going to modify here. I'm going to have 3, and then under the radical, I'm going to have x minus 4, and then plus 2. So I'm going to hit the over arrow to get out from underneath the radical. And what that did is it shifted my starting point over right 4 up 2. So I am going to go ahead and graph that. And I am just looking for sketches of this graph. I am not looking for precision here. But I do want to see the origin over 4 up 2. Okay, and any other points then that graph nicely. So like here, I have 5, 5. I can graph that pretty nicely. And then I'm just going to connect those with kind of that arching shape. And the domain and range. Well, the domain is going to start at 4. So x can be greater than or equal to 4. And my y value can be greater than or equal to 2. Previously, we'd done all real numbers, right? Negative infinity, positive infinity kind of thing. But that is not the case with the graphs of these radicals. So here I have a negative out in front of the radical, and then x plus 5, and then minus 6 on the outside. And what I see now is my origin has shifted left 5, down 6, and the whole graph has flipped across the x-axis. So my graph is now not going up from that starting point, but moving down from the starting point. So my origin point is at negative 5, 6. So negative 5, 6. And it's moving down and away to the right. So my domain is going to be still x greater than or equal to the 5, or negative 5. But my range is now going to be y is less than or equal to, because it's moving down, right, from the negative 6. So my domain and range, the point that it begins, right, that negative 5, negative 6, those numbers are used in your domain and range. You just have to decide if it's increasing or decreasing from that starting point. For example 2, we have an inequality. Y is greater than the square root of 3x plus 5. So let's type that equation in. So I have 3x plus 5, right? And what I see here is an origin, or not origin, but a starting point for my graph at the negative 1 2/3. So I need to go ahead and graph that. But I need to think back to Algebra 1 and how do I graph an inequality? Well, I remember back that if it is an or equal to, I use a solid line. And if it's not, if it's just greater than or less than, I use a dashed line, right? And y is greater than, so it's going to be above that dashed line. Now, I'm going to let you in on a little trick that Desmos can do for us. If I delete out this equal sign and I replace it with the y is greater than sign, it goes ahead and it gives me the line style that I need and the location of the shading. So that should help you be ready for your assignment today on lesson 5.3.